Hello and welcome to SudoKanard. We're here to solve these easiest Japanese sums that I created as a practice puzzle for the upcoming WPF Puzzle Grand Prix. It's not a Sudoku for once, but it's very close to Sudoku in a sense. So the rule is that in this puzzle we must place digits from 1 to 5 in the grid, and digits must appear exactly once in each row and each column, and there are two cells that must be shaded, let's say like this and like this, and then the other cells will be unshaded, and then the number in the margin will be the sum of the first few digits, and that is the first run of neighboring digits, not separated by black cells. Well, obviously I can't put digit 13 into this cell, so this is a bad example, but we could have say something like 3 here, or we could have 2 digits here with a sum of 3, which would be, for example, a 1 and a 2. So I put the link in the description if you want to solve the puzzle first. So this is a walkthrough puzzle where I'll explain how I constructed the puzzle, or more precisely, what kind of logic I found while setting this practice puzzle. So the first thing we'll notice is that in 3 instances I put face-to-face 2 clues. The second thing is that the sum of all digits from 1 to 5 is 15. Therefore, if the sum like this is not 15, it means that we have more than 2 groups. We have a group summing to 3 somewhere at the beginning, another sum at the other end, and there must be something in between summing to 9. So there are at least 3 groups, and we have only 2 black cells to separate those groups, so that the black cells must be somewhere in between. The black cells can't be at the border. So in all those instances, I can unshade those cells, meaning that there are digits in those cells and not black cells. And this too can only be done with 1 digit, so I can black this cell out and place a 2 in here. Now, this 4 clue could be a digit 4, or it could be 1 and 3. And this will have to be disambiguated at some point. Next, we see that this 3 can be either a single 3, same for this, or a 1 and 2. And this is true for both of them, and by that I mean that we're either in the situation where we have 1 and 2 here and 3 there, and in this case the black cells are here, or we're in the symmetrical position where 3 is here, 1 and 2 are here, and we have the black cells here. And what you see is that in one case we have 4 and 5 here, in the other case we have 4 and 5 here. So in both cases we have 4 or 5 here, and this is not a black cell. And of course, well, if this is a 4, then this will have to be a 5, but at this point we don't know for sure what is happening. So now where is the next place to look? This 13, so we know the sum of all digits is 15, so we are missing a total of 2. So we have a group of 4 cells and a 2 at the end. So the 2 will be somewhere here, the 4 cells will be somewhere here. So the options are 1, 3, 4, 5 here, black cell, 2 black cell, or perhaps those digits, 2 black cells and the 2 here, or the 4 digits, the black cell and the 2. Well, we know for sure that the 2 is somewhere in here, and the black cells are either sorry, the 4 digits are either here or there. So in all cases, in all scenarios, we have digits in those 3 cells. And this now disambiguates the situation with the 3s. One of them is this group, and the other is this group here with just the digit 3. And here this is 1 and 2, but we know that there is a 2 somewhere here, so that's the 1 and that's the 2. And here we will have 3, 5, and 4 somewhere, and the third digit is either here or there. So where do we look? This is also 4 or 5. Something of interest here is that this 6 can't be done with only 1 digit, because digit 6 is not available in this puzzle, so we can say for certain we can say for certain that there is another digit. So it could be 5 and 1, it could be 4 and 2, but it could also be 1, 2, and 3 here, with a single digit 5 there and a 4 somewhere in between. So we don't know at this point. But one place we can look is this 8 clue. So what are the options to provide a sum of 8? One option would be 5 and 3, but it couldn't be here. If this is 5 and 3, then this 3 must be in it, and 5 will have to be there because this is not the place, but then 8 is the first group of digit that is seen. So if we put 5 and 3 here, then 1, 2, and 4 must be there. And that doesn't work. So 8 will need at least 3 digits, and exactly 3 digits, because 4 is too many. And the only way to have, with our 2 ways of achieving 8 as the sum of 3 digits, one of them is 1, 2, 5, but there's not enough room for 1, 2, and 5 here with them separated from the 3. So 3 must be in this group, and it must be 1, 3, and 4. So it will necessarily be here because we still need to have the remaining digits to the left, to the right. So those are 1 and 4, and those are 2 and 5. So we know that those aren't shaded, those are shaded, and this 8 clue is satisfied. So is this 3, so is this 3. Now, where do we look? This 5 clue with a 1 and or a 4 must be completed with a second 1 or 4. And then this is a black cell. We have both black cells in this column. So this is not a 4. The 2 in the column must be here, and this is 3 or 5. So now let's move on to this other 8. So 3 options again. One of them is 3, 5, but we can't have 3 and 5 here because this is 3 or 5. So this 8 must be done with 3 digits. It won't be those 3 digits, it will be those 3 digits, and they will be 2, 1, and 5. So that this is a digit, those are not digits, and this is also a digit, and we can say a little more. That's a 3, that's a 5, and that's a 4. That's not a 5. Now, where else will we look? Well, this 8 is done, obviously. And we haven't looked at this 8. Now, what can this 8 be? Is it really here? Oh, what I'm seeing is that this 6 can't be 5 and 1 because of this. So this 6 will start with a 2, and that's a 5. And because of this, this is not a 2 anymore. That's the 2. So the outer region here is with this 2, and this is not a digit. And because of that, this 5 here is the sum of only one digit. Now, where do we look? This 6 here can still be 2 and 4, or 2, 1 and 3. What about this 8? We still have 3 options for 8, which are 1, 2, 5, 1, 3, 4, and 3, 5. But because of this, we won't have 1, 3, 5. If this is 5 and 3, then because of those 5s, 5 will have to be here. If this is 1, 2, 5, for the same reason, 5 will have to be here, but 2 can't be anywhere. So this is actually 5 and 3 with those positions. So this is a shaded cell. We have two shaded cells in this row and in this column. So those are digits, and they are 1, 2, and 4. So because of this, we can see that this has to be a 1, that's a 4, and that's a 2. And this 4 makes this a 3. We still need a 4 in this row, so it will have to be here. And this is a shaded cell. And those are unshaded cells because we already have 2 shaded cells in here. This 5 is done, this 2, this 13, this is still not resolved. This 6 will now be resolved with a 1 here, and this will be a 4. So that's the 1, that's the 4. And then this now must be a single digit, so that this 4 is fulfilled. And now we just need to finish the grid, so that's a 5, that's a 4. We still need a 1 and a 3 in here. So 1 is here, 3 is there. We still need a 2 somewhere here, but because of this 2, the 2 is here. And we'll finish with a 5 there. And I'm missing a 3 here and a 5 there, and a 3 here and a 1 there. And that's it. So this is my practice puzzle for easiest Japanese sums. And I hope you liked this puzzle. It's quite unusual for me to create something else than Sudoku, and it's been a very long time since I presented another type of puzzle apart from Sudoku on the channel, and I should definitely do that more often. Thanks for watching this video, and see you soon on SudoKanard.